Alright, so moving on in Algebra 2 to Chapter 9, Section 1, we're going to be looking at what are called inverse variations and also jointly varied functions. So starting off, let's talk about what a direct variation was, which we've discussed before. And basically, as one variable changes, the other variable changes at the same rate. So if the x goes up by 1, the y goes up by 5. That would be a direct variation. Okay, think of it more like an arithmetic sequence. Okay, there's a consistent pattern of adding the same number over and over and over again. Okay, adding 6 each time, adding 12 each time, subtracting 4 each time. Okay, but one thing that must be true is that you must start at the 0 for your direct variation. So when x is 0, the y must also be 0, which then leads us to this equation down here, y equals kx. Okay, so for direct variation, the equation that you would use would be y equals kx. Okay, so now what we're going to be looking at in this whole section is your inverse variation. And your inverse variation is basically a ratio between two variables and a constant. So there's two different ways that it can be written. One is to find k, which is the multiplication of your x and y. So if you multiply your x and y together, they should always get the same constant. Or the other way of writing it, if you want to have it set up as y equals, it'd be y equals k over x. Okay, so y equals k over x would be your equation, which this is just the ratio because it's like y over 1 is equal to k over x. Okay. Alright, so that's your inverse variation, your basic setup for it. Okay, so here's an example of where inverse variation works. So let's say you're driving a car and you want to travel 100 miles. If you're traveling at 50 miles per hour, how long is it going to take you to make that 100-mile drive? Right, it's going to take you about 2 hours. Okay. Now, what if you're traveling at 25 miles per hour? Right, it's going to end up taking you 4. And what if you're traveling at 100 miles per hour? Right, it's only going to take you 1 hour. So as you see with this isn't like an arithmetic sequence where it's as the x increases by 1, the y is increasing by a consistent number. This one you see they're decreasing. You start off with 100 and then you go down to 50 and then 25. It's not a constant change for this. Okay, and this is a inverse variation. It's basically going down at a ratio. Okay, it's being cut, I guess in this case, in half for these numbers. Well, that's what it is. So here's your two different, your direct versus your inverse variation. So your direct variation looks like that blue graph to the left. It's y equals kx, and again, it always starts at the middle, or at the origin, at 0, 0, and then it increases or decreases at a constant rate, so it's going to be a nice straight line. Your inverse variation, on the other hand, is going to end up looking like the red graph on the right, where it starts at infinity and then it drops down and it kind of arcs down and goes off into infinity along the x-axis, approaching 0. And that's what it would be. If you think about this with the 100 and all that, you saw that those numbers were going down. And the faster you go, the closer you were approaching 1, but you can never go so fast that you're there at 0, and you can never go so slow that you're there at infinity. Okay, if you travel at a speed, you will get there at some time. Okay, so let's say we want to write one of these inverse variations. So we know that x and y vary inversely. And we know that x is equal to 3 when y is negative 15. And what we want to do is we want to write the function that models this variation. Now remember, in our equation, it's y equals k over x, or xy equals k. So what we have to do first is we have to find k. And the easiest way to find k is to just either set up the equation as y equals, or easier, remember k is equal to 3 times negative 5. So k is always going to equal to the multiplication of an x and a y that are related to each other. So that means our k is negative 15, and then we rewrite our equation, plug it back in, and we get y is equal to negative 15 over x. Okay, that negative sign can go in either one. Usually you put it on the top of it. But there would be our equation. Okay. All right. Okay, so if that's our equation now, I want you to find y when x is 30. So using the y equals negative 15 over x, find y when x is 30. Okay, so this is as easy as just plugging it in. So you plug a 30 in, and you end up with your answer of negative 1/2. Negative 1/2 would be your answer. So when x is 30, y has to be a negative 1/2. Okay, so let's assume that we have a variation, but we're not given an equation, but we're given a point that is told is true about it, and then we're told another point, but we're missing one of the variables. So in this case, we know we have an inverse variation, and one of the points that can be used is 510. The next question is, what's the x value when the y is 17? Is basically what that second line is doing. So first thing we have to do is find our equation and then just plug in our number. So again, easiest way to find k is just to multiply the x and the y that you have. So k would equal 50. Okay, so k would equal 50, which then gives us our equation. Which then gives us our equation of y is equal to 50 over x. Now we plug in the 17. So we end up with 17 is equal to 50x over x. And then you're just solving. Ends up getting you x is equal to 50 over 17. Just using some basic algebra skills to be able to get that x by itself. And we get 50 over 17, which is 2.9411. Okay, so the next thing after inversely is that we have joint variation. So a joint variation is if you have more than just your two variables. So if you have more than just your x and y, and you have to add other stuff to it, you would say that they've been done jointly. So here's a few different phrases that you would say. So z varies jointly to x and y. Basically, it means that the x and y are together. So the x and y with k, because you need a constant to go along with this, all contribute to z. Okay, and it's all basically a straight multiplication. It needs the word inverse for you to do a inverse variation. Okay, so z varies jointly with x and y, and inversely with w. So as you see, the jointly xy, they stay on top, and then inversely you got w is on the bottom, because the inverse means you're going to be dividing it. And don't forget, always put your k or whatever your constant is. Last one is z varies jointly with z and inversely with the product of y and w. So you see it's the product of, so you mean both those need to go underneath and for it to be inversely. Okay, so let's do an example where you would have to write one of these. So F is the gravitational force between two objects with mass m1 and m2, and d is the distance in between. G is your constant. Okay, so G is your constant. So take a second, write the formula for F varies jointly with m1, m2, and inversely with the square of the distance. Don't forget G. Okay, so this is Newton's law, and so the equation ends up looking like this. So G m1, m2 all over d squared. Homework for the section 1.